Mud Matters, presented by Science at NASA. Water may be the most influential substance on Earth. It covers more than 70% of our planet's surface, plays a key role in weather and climate, and nurtures life itself. Earth's deep oceans are unique in the solar system, and their globe-spanning majesty, as seen from space, is a testament to the primacy of H2O. Oceans, however, are just the most eye-catching repositories of water. The substance can be found in lesser amounts in almost every nook and cranny of the planet, and researchers know it is important to keep track of water everywhere. For example, in mud. Believe it or not, NASA has just launched a satellite that can track water in the muddy slosh under your feet, as well as other forms of water in the ground. The name of the mission is SMAP, short for Soil Moisture Active Passive. The satellite left Earth on January 31st, rocketing into the sky on board a United Launch Alliance Delta II rocket from Vandenberg Air Force Base in California. There's more to soil moisture than mud, of course. With data from SMAP, scientists and decision makers around the world will be better equipped to understand how Earth works as a system, says Christine Bonnickson, SMAP program executive at NASA headquarters. It will show us the down-to-earth impacts of soil moisture, from floods and drought to weather and crop yield forecasts. SMAP senses soil moisture using an extraordinary mesh antenna. A large 6-meter mesh reflector antenna will deploy like a pop-up tent and spin lasso-style at approximately 14 revolutions per minute. Through this antenna, both the radar actively pinging the ground below with microwaves and the passive radiometer listening to the Earth's emissions can gauge the moisture in soils along the satellite's ground track. Circling Earth in a 426-mile altitude near-polar orbit, SMAP will be able to produce high-resolution moisture maps every 3 days. Water in the soil can exist in many forms. As it orbits, SMAP will be able to detect whether the ground within its 3-kilometer-wide footprint is frozen or thawed. This capability, which is unique to SMAP, will assist scientists in determining the growing season length and how much carbon plants are removing from the atmosphere each year, thus improving our current understanding of global warming. Additionally, SMAP will enhance our ability to respond to weather-related catastrophes by contributing to flood prediction and drought monitoring. Soils are like sponges, explains Erica Podest, a scientist on the SMAP team at NASA's Jet Propulsion Laboratory. They can hold a certain amount of water. If we know the amount of water in the soils, and we know that there's a big rainstorm coming, for example, and that the soils are near saturation, then we can predict that that area might be at risk for flooding. Clearly, mud does a lot more than just lie underfoot. The data gathered by the SMAP mission will be invaluable both within and beyond the science lab. Says Podest confidently, I think it has the potential to touch everyone's life. For more information about planet Earth, stay tuned to science.nasa.gov.